Hi guys, in this video lecture, we will explain how possible structures of structural isomers can be drawn from any given molecular formula of an organic compound by using the concept of double bond equivalent dB and its value. Look at to this table. This table shows various molecular formulas of organic compounds and their calculated dB values. This is another table which shows the B values and the possible numbers of double bonds, triple bonds and ring in any given molecular formula of an organic compound. We have already explained and discussed in detail these two tables in our previous lecture number 6 and 7 on stereochemistry. Now here in our this lecture we are going to explain and discuss how possible structures of structural isomers can be drawn from the B value of any given molecular formula of an organic compound. Let's we get started with molecular formula C3H6, this one. The dB value calculated for this molecular formula C3H6 is 1. Now we have two possibilities A and B. The first one possibility is that the compound may contain one double bond and no triple bond and ring. The second one possibility is that the compound may contain one ring and no double bond and triple bond. Thus the given molecular formula C3H6 may have these two possible isomers. The dB value of this isomer is 1 as it contains one double bond. Again, the dB value of this one isomer is also 1 as it contains one ring. It may be noted that the dB value can help us to find out the number of possible structural or constitutional isomers and not the stereoisomers of any given molecular formula of an organic compound. This is another molecular formula with dB value of 1 and contain an oxygen atom. As this molecular formula C3H6O contain an oxygen atom, so we can imagine that its possible structural isomers may comprise of aldehyde, ketone, alcohol, ethers and some ring compounds. These are total 9 possible structural isomers which have been drawn from this molecular formula C3H6O. Out of these 9 possible isomers, these 6 are open chain and the remaining 3 are cyclic in nature. Look at to this molecular formula C4H8 with the B value of 1, and these are the possible structural isomers which have been drawn from this molecular formula C4H8. Among these possible isomers, these 3 are open chain and the remaining 2 are cyclic in nature. Likewise, the above molecular formulas, this is another molecular formula C4H8O with dB value of 1 and contain an oxygen atom. As again it contains an oxygen atom, so we can propose that its possible structural isomers may include it aldehyde, ketone, ether, alcohol and some cyclic compounds. These are 17 possible structural isomers which have been drawn from this molecular formula C4H8O. Out of these 17, isomers. These 6 are open chain and the remaining 11 are cyclic in nature. This is another molecular formula C5H10 with dB value of 1, and these are 10 possible structural isomers which have been drawn from this molecular formula C5H10. From the look of these isomers, we can say that these 5 are open chain and the remaining 5 are cyclic in nature. Now we are going to explain how to draw possible structural isomers from given molecular formula of an organic compound with dB value of 2. This table shows dB value of 2, and these are the possible numbers of double bond, triple bonds and rings in any given molecular formula of an organic compound. Let's consider molecular formula C4H6 with dB value of 2, and these are the 9 structural isomers which have been drawn from this molecular formula C4H6. Out of these 9 structural isomers, these 4 are open chain and the remaining 5 are cyclic in nature. Now again we can explain how to draw possible structural isomers from any given molecular formula of an organic compound with dB value of 3. This table shows dB value of 3, and these are the number of possible double bonds, triple bonds and ring in any given molecular formula of an organic compound. Look at to this molecular formula C6H8 with dB value of 3. A total of 47 possible structural isomers have been drawn from this molecular formula. Out of these 47 structural isomers, 21 are straight chain and the remaining 26 are cyclic in nature. We can also draw possible structural isomers from any given molecular formula of an organic compound with dB value of 4. This table shows dB values of 4, and these are the possible numbers of double bonds, triple bonds and ring in any given molecular formula of an organic compound. Look at to this molecular formula C6H6 with dB value of 4, and these are 9 possible structural isomers which have been drawn from this molecular formula C6H6. Out of these 9 structural isomers, these 2 are open chain and the remaining 7 are cyclic in nature. So this was all about how to draw possible structural or constitutional isomers from dB value of any given molecular formula of an organic compound. Thus this shows that dB value can help us to draw possible structural isomers from any given molecular formula of an organic compound. Thank you for watching my video lecture. If you find my video lecture interesting and informative, then please like, comment, share and subscribe my channel for more videos.